Hello everybody, this is Ria Nainan and Pranaydeep Singh from second year CSE BDA section, and the project that we are going to talk about is on semantic networks. Pranaydeep will explain more on semantic networks.
So, thank you very much for that great introduction, Ria. So, semantic networks are an alternative of predicate logic for knowledge representation. In simple words, it is a way in which we can represent knowledge in the form of graphical networks. The basis of these graphical networks is formed by nodes. Nodes are what we represent different objects by, and they are defined by the relationship they have with other objects, which is shown through the use of arcs. Semantic networks can also categorize the objects in many different forms, and can be linked to many and also helps us link one object to many others. They are very easy to understand and can easily be extended uh, to get more and more objects in semantic networks. Change this slide, please. So, as I was talking about, semantic networks have many merits, and that is why they are the industry standard today. First of all, they are very simple and easy to comprehend. A person with no prior knowledge of the subject can look at a semantic network and very easily understand how many objects are there and what kind of relationships they possess with other objects. It is very efficient and does not have a lot of space requirements. The clusters are also easy to relate to the knowledge that we want to present to. It is very flexible and easy to visualize. It is also a very natural representation of knowledge, uh, and conveys the meaning of the objects in a very easy and transparent manner. Now over to Rian Enan for some of the demerits of semantic networks.
Okay, just like there are a lot of merits for semantic networks, there are also a lot of demerits when it comes to it. First one is that inheritance causes problems. Links on objects represent only binary options. They're interactable for large domains. They don't represent performances or meta knowledge effectively, and it's difficult to express some properties using semantic networks like negation, disjunction, etc. So let's move on to the problem. The problem that we were given with is to prepare a semantic network to represent the following knowledge. So we were provided with five statements. The first one is that Jerry is a cat. The next one says Jerry is a mammal. C, Jerry is owned by Priya. D, Jerry is brown colored. And E, all mammals are animals. So what we're actually expected to do is to create a relationship between all the five statements that are given. Like for example, let's take Jerry is a cat. So here, let's create a node. Let's create a node called Jerry and place it in the middle. So the first statement says Jerry is a cat. So let's create another node called cat, and let's link cat and Jerry together. So together it says Jerry is a cat. The next statement is Jerry is a mammal. So let's create another node mammal and link it to cat because we already know Jerry is a cat. So let's link mammal to cat. So it says Jerry is a mammal. The third statement is that Jerry is owned by Priya. So let's create another node called Priya and link it with Jerry. So it says Jerry is owned by Priya. The next statement is that Jerry is brown colored. So let's create another node here called brown, and we'll link it to Jerry, which says Jerry is brown colored. And the last statement is that all mammals are animals. We already have a node here called mammal. So mammal is going to be common to both statements B and E. So from mammal, we'll create another node called animal, and that thing says all mammals are animals. So together, this is how the whole semantic network looks like, and this is the solution to a
So
problem.
as you can see that objects in here are defined by the relationship they have to other objects. For example, cat and mammal possess a one-to-one relationship, where first of all, mammal has a relationship of what is a cat. It is a mammal, and Jerry also has a relationship with cat in the same manner, and so cat has a one-to-one. It is going from mammal to Jerry and has a one-to-one relationship. But we can see that Jerry has a one-to-many relationship. It has a single relationship with cat, but then it also has two other relationships, that is the color and who it is owned by, which is brown and Priya respectively, and so it has a one-to-many relationship. This is our presentation upon semantic networks. Thank you very much.